Hello and welcome to our framework attack talk, a comparison of microservice frameworks in Java. Yeah, I'm Hendrik Ebbers. I work at a company that is called Karakun. I'm the co-founder of that company. And I do a lot of Java-related things. So I'm the founder of the Java user group here in Dortmund in Germany, which is my hometown. I worked on JSRs. I was part of the expert group for the bean validation JSR, for example. I'm a Java 1 Rockstar, Java champion, and I'm part of the Adopt OpenJDK steering committee. And today I will talk together with Karsten about microservices.
Yep. Hi, I'm Karsten. I'm a colleague of Hendrik, working also for Karakun. I live also in Dortmund, and yeah, I'm quite involved in Eclipse projects. I'm part of the Eclipse platform team, and I work also for Eclipse Xtext, and yeah, contribute to a couple of other frameworks. And yeah, and today we want to talk with you a little bit about microservice frameworks in Java. Hendrik, could you advance? Okay, so after a very short introduction on what microservices are, we want to highlight the four most popular Java microservice frameworks, namely SpringBoot, Quarkus, and Micronaut and MicroProfile. You may know one or some of them, and we want also to discuss shortly other frameworks. We want to give a special hint about containerization and look deeper how these applications are and run in containers. And yeah, and as it is a comparison here, we want to not go too into deep. We only have half an hour for frameworks. Have to advance quite fast. So Hendrik, could you take over again?
Yeah. So let's start with the first topic and let's have a general look at microservices and what microservices are. So in general, a microservice can be more or less everything, right? It can do several things. It can be event-based, it does event streams and so on. What we did for our talk, we had a look at, let's call it a classical microservice, which is a microservice that on the one hand has some input channels. Normally they are REST-based, where, for example, a client or another service can communicate with the microservice. And on the other hand, the microservice provides some data that are coming, for example, from a SQL database. So this is how a microservice might look like. So it's a small service that has one explicit feature that is implemented by this service, in this case, providing data that is coming from a database to a REST endpoint. There can be other things, other functionalities, but this is a general one. And when having a look at such services, they are not really depend on Java. So in general, you can, since we concentrate on Java today, you can create microservices with more or less any programming language that you want to use. Okay, maybe there are some old ones, like for example COBOL, that you cannot really use to create microservices. That is what I thought before I started to work on this session. So this is the first lesson of this session. Never underestimate the power of the internet. You will find everything in the internet, even people that use COBOL to write microservices. Okay, anyway, but let's have a look what a microservice should do, and I hand over to Karsten for that one.
When we look at microservice frameworks, what do we expect? We want to have easy start. It should be easy to learn to write microservices. We would want to have good guides. yeah, an active community that supports us. We want to have an active framework with hopefully lots of maintainers. And if we think about going into production, it could be interesting also to have some kind of support for older versions of the framework. So long-term support, professional support by the vendors behind that. And this is why we came to those four frameworks that we want to show. From the implementation side, we expect from Microservice that it runs very fast with low resource consumption, that you start up fast, and that it's possible to scale it up on yeah, a containerized environment like in Kubernetes, and as fast as possible. From the technological side, Hendrik, we expect that we have typically the possibility to call REST services. That's the use case that we focused on. But this doesn't mean that's everything. There's a couple of other kind of microservices that use event-based systems like Kafka or MQTT. Or even serverless, so just functions. Typically, you want to access some kind of data storage, be it relational or non-relational. You want to have support for security, and as it is, as a microservice should be technology agnostic. JSON is the matter of serialization. So now let's look at our competitors. And first competitor is the Quarkus framework. Quarkus is the newest candidate on our list. It's actually just 2 years old. Crafted by Red Hat, and makes Quarkus quite special is that it comes with GraalVM support out of the box, and it is based on a couple of standard like some from MicroProfile, which is our next competitor, and a little bit special. So we have gained some numbers here to our candidates, and MicroProfile is always very low, but that's because the MicroProfile is just for itself. It's more a specification, and this specification is quite some vendors like Jara, Tommy, and so on. Those provide the implementations for the frameworks that are actually compiled to the micro. Hendrik?
Yeah, so, where's my focus here? So the next one is the one that maybe all of you know, which is SpringBoot. It's quite the oldest of the frameworks that we will have a look at. It was first released in 2030, and the owner of SpringBoot is Pivotal. And yeah, as you can see in the elevator pitch, I already said it. So it's a major and leading microservice framework. On the plus side, it has maybe the biggest community and ecosystem from all the frameworks that we will have a look at today. And next to this, we have a quite new one, which is Micronaut, that is owned by the Micronaut Foundation. And that was released, or that had a first release in 2017, so it's quite new. And here's the special things about a Micronaut are that it's provide a non-blocking and reactive framework that is perfectly to create microservices and even serverless functions. And next to this, Micronaut already provides a quite good GraalVM support, as we will see later. Okay, so when you want to start with any one of those four frameworks, it's quite easy because all of them provide a so-called initializer, which is at the end a web page. where in the UI of the web page, you can configure or do a first configuration of your application, like defining the Java version that you want to use, define which version of the framework you want to use, define things like the artifact ID, group ID of your application. From time to time, you can choose if you want to use Maven or if you want to use Gradle to build your application. And you can already add extensions like when talking about Spring, for example, Spring Data JPA to directly access a JPA by using JPA, a database, and a lot of other extensions. So this can be done by the initializers, and by using those, you can download your project or a template for your project that you can easily import in any IDE and directly start with your microservice project or application. Okay.
Let's now look at timeline. We looked 3 years back how the projects evolved, Hendrik. Here from SpringBoot, we can see that it has already long life and releases that are maintained. So here we have support for the framework. As said, actually, because we don't have the framework itself specs. Hendrik, can you advance? We have some at certain point of times that the project compiles a set of specs to those frameworks in that version 3 and so on. Let's have a look at Quarkus. On the Quarkus side, Micronaut, sorry. Micronaut is a typical framework which just maintains the current version and advances and releases quarter. And for Quarkus, we see that it started off with a pre-mature version quite a while ago, and 1 year ago they released from then on monthly releases. Now let's have a short look at how typical REST endpoint looks like in different
source code.
Yeah, source code. Not much, not so. Basically, we have some REST resource which provides which is our endpoint, and we expect, for example, that objects are automatically converted to JSON thanks to JSONP or whatever is behind that. Let's have a look. Quarkus solves this. Quarkus and MicroProfile use the JUX-RS standard to annotate resources and methods and parameters. And if we look at Boot, this looks slightly different. They have their own annotations, and basically you have always the same say rows. Here we have some method which is accessed by a get. This is specific to Spring. Quarkus to also understand Spring annotations. And let's have a final look at Micronaut. Surprise, looks only the names are different, but yeah, we are here in this example. We also see how Micronaut supports reactive programming with RX Java. So Hendrik, and do you take over to data access?
Yeah, the next example we will have a look at is how to work with a database. So in general, we could have a look at much more functionalities that can be in a microservice, but as said, we only have half an hour, so we only have a look at those two functionalities and how they can be implemented by the framework. So the second one is database access. And here, all four frameworks that we want to have a look at use more or less the same pattern, which is the repository pattern. So what you can do is you can provide repository classes. Here you see how this is done by Quarkus. So there's a panache repository interface that you can implement and then provide methods to get your data by using the panache API internally that provides a Fluent API that lets you write quite nice and good looking code to query the data. When we, for example, go to SpringBoot, here we see even more magic, because when using Spring Data, in this case, Spring Data JPA, we do not even need to provide a class and use a Fluent API or something like this to exit the data and to create a repository. In Spring, we only need to provide our own interface that extends the Spring CRUD repository. And then we can provide methods like, for example, find by name, find optional by name, and so on. And Spring Data internally, by the name of the method, creates the queries for us. So this would be really a select asterisk by name for the movie table. If you have more complex queries, you can provide them by an annotation and then putting the query in the annotation. But for the simple things, you can really just put in the name of the method and Spring will create the query for you. At the end, it's the same for Micronaut. Here we see it's more or less the same as we've seen in SpringBoot. It's another API. So this is the data API from Micronaut, but they use the repository pattern too. And here you only need to provide an interface too. A little bit different is it when you have a look at MicroProfile, because MicroProfile is based on basic JPA or plain JPA. So here you only have the JPA API, which allows you easily to create repositories by using the repository pattern. But as you can see on the slide, you need to write more code. At the end, it's up to you if you like to have the magic that maybe some people don't understand and make errors, or if you like to do it more explicit, like we see it here in the example, and directly using the JPA API. So this is about database access and the difference in the API here. And again, here you can see they are all quite similar to each other. Since we're running, since we only have half an hour, we only looked at these 4 frameworks. Karsten, maybe.
Yeah, of course, you find a couple of other frameworks. Drop Wizard is maybe the oldest on that list. Vertex actually is under the hood of Quarkus again, and Helidon from Oracle is even provided in 2 versions. One of them is a MicroProfile implementation. I read today that they now support the latest MicroProfile version 3.3. And actually, it's not really even defined what makes a microservice framework. Even when you look at lists of microservice frameworks in Java, then you will see also things like Jersey or REST Easy, which are not really microservices, but a part of microservice frameworks. Okay.
Okay.
Hendrik?
Yeah. So whenever you create a microservice, I mean, why you at all create a microservice is because you want to have small services that you can easily deploy in a system and scale easily inside a system. And to do so, there's one great technology that evolved within the last, I don't know, 6 years, something like that. That really helps you to provide such functionality. And this is the container functionality, in this case, especially Docker as a tool that helps you to create containers out of your application. And what we did for the different microservice frameworks, we had a look at how you can use Docker to create containers out of those or how you can put your application that is based on those frameworks into a container. For some of the frameworks, this is quite easy. Here you see a Docker file. If you are not familiar with Docker, what we are doing here, we extend a Docker file from adopt OpenJDK that contains JDK 11. Then we copy our jar into that container, expose the port 8080, and then start our jar. So the container is based up in 3 layers. First of all, we have Linux, then we have the JVM, and then we have an application. Once we did that, we can build the container and then easily start it. And when you do this, you will see something like this. So these are all the commands that are executed when building the image. On the right side, you can see the size, how the commands affect the size of the image. And while there are some that don't affect it at all, there are some that affect it in a quite high amount. And we can move them back to where they are coming from, especially to the Linux layer, to the JDK, and to our application that is based on the microservice framework. For SpringBoot, for example, this looks like this. So we decided for all to have Ubuntu as a base. Then we have adopt OpenJDK 11 as the JVM. And then we have the microservice framework with the application on top. So our application was really small. It was just one endpoint with one database access. So mostly everything we see here is coming from the framework. When having a look at the different frameworks, and here we only look at Micronaut, Quarkus, and SpringBoot, because Eclipse MicroProfile is somehow special. Karsten will show this. We can see that Quarkus provides the smallest, or needs the smallest image, because Quarkus as a framework, as that, is kind of smaller than Micronaut or SpringBoot. But what we can see here too is that against the JVM and Linux, the difference is really, really small. Okay, but that's not all. We can do much more cool stuff. So I give up to Karsten, who will give an introduction to GraalVM and GraalVM in Docker.
And this is actually quite interesting when you want to run microservices. With GraalVM, you can create a native binary application, which includes a stripped down Java virtual machine inside of it. For Quarkus, a 13 megabytes binary that you get out of the compilation process. And what it makes this especially interesting, the memory consumption is quite lower, and especially startup time is way faster. On the other side, quite a while to build such a binary, so it's not for daily use. You would use this if you finally deploy your application to production, and also you this so no one wants to debug native binaries, but you can have both of that. Can you advance, please? Hendrik already mentioned that MicroProfile is a little bit special in regards of the in MicroProfile we rely on application servers or containers like Wildfly or OpenLiberty. Of course, they have some kind of size. They are not small, but that you finally deploy is really what comes out of your typical development process. They're developing multiple versions of your applications just adds a layer on top of your basic infrastructure. Okay, now let's have a look at startup times. We measured the time until the different implementations REST endpoint, and especially surprising on the both ends. We were surprised that Pajara took 16 seconds until the first REST call came through. And on the other side, we have the GraalVM implementation, which answered after 300 milliseconds. And in between, we see that Spring is somehow in the middle, and the others are a little bit faster in starting. Okay, can you advance? For the build times, as said before, when you build the binary for GraalVM, this takes quite a long time. and on the other side, Spring was here fastest, and Open Liberty also takes quite a while. They do quite some instrumentation and analysis during the build, and also testing. So that's what you have as a typically workaround. Turnaround during your development process. Okay. Hendrik?
Yeah, that's about the run and build time. Let's go back to the size of the images. So we've seen before that we have this Linux, JVM, and application layer. To be true, here we can work on it too to get it a little bit smaller. So first of all, we used Ubuntu as a Linux layer. Here we can use much smaller Linux layers. One example is Alpine Linux, for example. Next to this, we can use jlink to create a JVM or a runtime environment that fits to our application and that do not contain all modules of the JDK. When you do this, for example, for a small SpringBoot application, you can run it on an Alpine Linux that is about 10 megabytes and a jlink-based JVM that is about 55 megabytes. And then on top, you, for example, have your application. And now you can see that now it's maybe already a difference if you use Quarkus or Spring or something else, even if the difference there is only 10 or 20 megabytes. Now it has a much higher effect on the total container. But in general, what you can see about or say about the support for Docker for all those frameworks first of all support Docker, and all have quite good solutions how you can Dockerize your application. At the end, it's up to you, right? If it's more important to you to have a smaller image size, if it's more important to you to have smaller image layers like you have with MicroProfile, if you want to update a lot or your application very often, then that is a quite good benefit. If the build time or the startup time is important for you. Another thing that if we're running out of time, we cannot have
3 minutes left, so please advance to the conclusion.
So let's have a look at the advanced features of microservices, and we will do this quite fast because, as said, we're running out of time. So there are a lot of more features that normally you should have a look at when deciding what framework you want to use, like the tracing or monitoring support, configuration, cloud configuration, if it has a service discovery, if serverless functions are already supported, like Micronaut, for example, does, how the reactive APIs look, and, for example, how authentication strategies the framework supports by default. Yeah, so 2 minutes left, so let's have a look at our general conclusion of our comparison.
Before we do this, we have one question, Hendrik. What tools do we prefer for testing of microservice frameworks? So actually, I would first say, I use as much as possible testing with unit tests inside, and not from the outside. But when we have when we want to test the services themselves, each of the frameworks provide different support for testing frameworks like Rest Assured, and they are quite easy to use. So that's
it's the same for me. JUnit is perfect. If you want to test your client endpoint, then you can easily set up with Spark another server. If you want to test complex things, you can, for example, use Test Container, which is a perfect framework for testing. Okay, yeah, at the end, when having a look at the frameworks, I mean, here we can see that in general, they're all fine. They all have the same license. They're all, since at least 2 or 3 years on the market, they have quite good release cadence. They have a lot of committers in general. The APIs are different, some of them based on JSRs like JAX-RS, CDI, or JPA. Others have their own implementation of APIs, but in general, they are all working fine and provide quite good APIs. Karsten, maybe?
Yeah, and all of them, of course, are perfectly supporting containers. For GraalVM, only Micronaut and Quarkus bring out of the box support. Actually, it's quite a little bit harder to support that for Spring Boot, because VM you are not allowed to use reflection, and Spring heavily relies on that. So it's quite some work that you have to do to enable Spring applications for GraalVM. Image sizes and startup times we have seen, so they all respond differently there. And here on the overall, Quarkus left the best impression here. So we are now out of time. So thank you for your attention. Please reach out to us on Swapcard.
Or at Twitter, you see at Hendrik Ebbers at Thoms. You can, if you have any additional questions, you can use Twitter too. So
thank you.
Thank you.
Bye bye. See you later.
See you. Okay. Bye.